Today's lessons are 12.6, surface area and volume of spheres, and 12.7 we'll touch on in a little bit. So spheres gets its own lesson because they aren't similar, just like prisms and cylinders had a similar formula, and cones and pyramids had similar formulas, right, to each other. Sphere is kind of its own deal. So sphere has a surface area of 4 pi r squared. The way to think about this is if you think about the covering of a baseball, how it has kind of 4 circles, even though they are attached slightly differently. The 4 circles cover the whole baseball, and that's where the 4 pi r squared kind of comes from. Not that it comes from baseball, but that's kind of a way you can think about it. Or softball, if softball's your thing. Volume of a sphere is 4/3 pi r cubed. Now the great thing about spheres are you have radius. That's it. Plug it in. So most of these problems I've combined, and I just say I want surface area and volume of object A, and then that's what we're going to do. So starting off, surface area and volume, we've got not radius, right? This is all the way across, side to side. I had a center, but it's kind of faded out. But it's 14 feet is our diameter, so half of 14 is 7. And now I'm ready to go. Surface area is going to be 4 pi r squared. Well, r is 7. So 4 pi times 7 squared. Plugging it in, we get 196 pi. And then we calculate. And as again, as a reminder, using Desmos. Right? Desmos.com/scientific. If you don't have a great calculator on your computer, even just the basic calculator on your computers aren't always the best. So 4 pi, radius was 7 squared. 615.75. I didn't even hit the multiply button. It does it for me, right? You can still stick a multiply in there. It won't change your answer. But, yeah, it's pretty quick, pretty simple. So 4 pi 7 squared, 615.75. We are rounding to the nearest hundredth. So after that, 2. So therefore, it stays at 0.75. Next one is 4/3 pi times 7 cubed. So 4/3 pi r cubed. We get 1,372 pi over 3. It wasn't a nice number, didn't simplify, and we just plug it in. Now, generally, when you plug this in, this would be considered the exact answer if something like this were to come up on a standardized test. And I use these squiggly equal signs to say approximately because we rounded, right? It wasn't exactly 1436.76. So again, plugging it in quick just to show you one more time on Desmos. So this time we have 4/3, so 4 divide button 3. And then again, typically at this point here in the denominator, you need to hit the right button to get out of there. Pi times 7, and then this is the power button, to the third power. Give me 1436.755, so that will round up to 1436.76. Next one, we have radius is 6, so we just plug it in, right? Same idea here, 4 pi 6 squared. 144 pi, 36 times 4, and 452.39 feet squared. Now notice, units surface area square, units for volume cubed. I'm not emphasizing it a lot necessarily at this point, but when it says volume, I need cubic units. Surface area, square units. Volume 4/3 pi times 6 cubed, 288 pi, which is exactly twice this number. We get 904.78 feet cubed. Moving on to one more. We've got to find the surface area and volume. Checking 8 is not the radius, it's a diameter. So divide by 2, I get 4. 4 pi 4 squared gives us 64 pi, which is approximately 201.06. Volume 4/3 pi 4 cubed gives us 256/3 pi, which is 268.08 inches cubed. And one word problem around this, the surface area of a sphere is 36 pi meters squared. Find the radius of the sphere. Now this could also read find the volume, right? We could go kind of backwards that way as well. So we've got 36 pi is 4 pi r squared. Divide by 4 pi on both sides. We're going to get 9 here. The pi's cancel. So 9 is what number squared? Radius is 3. And then we just grab 1 of the label, meters. So that is lesson 12.6. 12.7 is similar solids. For solids, aka three-dimensional figures, to be similar, their dimensions need to be consistently proportional. Same idea as proportional before. However, what it means is basically we have a 3-number ratio, right? 2 to 4 to 8. Is that similar to 2 to 2 to 4? No, these two match, these two didn't, so they're not proportional, right? 2 to 4 and 4 to 8 are similar, but 2 to 2 are not. So not consistently proportional. All sides need to be proportional. Now, how about here? 2, 4, 8 to 3, 3, 6. 2 to 3, 4 to 3. That doesn't work, right? 2 to 3, this one would have to be 4 to 6, and it's not. 8 to 6 is also not. So then lastly, we're comparing B and C. 2 to 2 to 4, 3 to 3, so 2 to 3, 2 to 3, 4 to 6. All proportional, therefore it is similar. So A and B and A and C are not similar. However, B and C are similar. Now this theorem may look a little bit like, wait, what? But what it really is we're adding just a third dimension to what we learned in lesson 11.3 about similar polygons, right? Or similar two-dimensional figures, right? And so if two similar solids have a scale factor of sides of A to B, their corresponding areas, aka surface areas ratio, would be A squared to B squared, and their volumes are A cubed to B cubed. And we'll prove that in a second. Just a short mathy version. And so we've got this ratio. They like to use R1 over R2, just comparing these radii, but I would just say A over B equals R1 over R2. Surface area of 1 over surface area of unit 2 would be them squared, and volume is it cubed. So again, side ratios is going to be the same as perimeter circumference ratios. The side ratio squared is area surface area, and lastly, cubed volume area. This is one of those formulas that are not given to you. You just need to remember them. Now you already have the first two. We only added a third one. So verifying the theorem, we're going to say P1 is just your normal prism, but prism 2, piece of 2, has 2 times the dimension as P1. So that therefore it is similar, right? We have a 1 to 2 ratio, and so we're just going to say prism 1 has length, width, and height. Prism 2 has 2 length, 2 width, 2 heights, and now we're going to find their volumes and compare them. So volume of prism 1 is length times width times height. Done. Volume of prism 2 is 2 length times 2 width times 2 height. 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8 length width height. So when we compare them, length width height over 8 of them, right? So this over this, we get the length width height cancel, we get 1 over 8. Well, how is that related to that 1 to 2? This is 1 to 2 to the third power, right? Because 1/2 times 1/2, 1/4, times 1/2, 2 times 4 is 8. So that is a mini proof of that theorem. We got a couple problems for you. And we've got cube C has a surface area of 54 units squared, and cube D has a surface area of 150 units squared. They're also similar figures, by the way. Find the scale factor of C to D. So we're doing 54 over 150 is going to equal C squared over D squared, or C over D squared. And so we want to simplify that. Now again, on a calculator, showing Desmos for how many times again, but 54 over 150, let me clear it out. And we have 0.36. Well, what if I want a fraction? Hit this button, 9/25. Bingo, that's what I need. So that's 9/25, and this is this squared. I want the scale factor, which is the sides. Right, reminder, scale factor is A over B. So if I want C over D, because those are the letters I use for this one, we're going to square root that. Square root of 9 is 3, square root of 25 is 5, so the answer is 3 to 5, and I made a typo there. It's not 4, 3 to 5. Okay. Sorry, fixing that. So now we have find the ratio of volumes of C to D. So now we're looking for C cubed to D cubed for volume. So now we have that cubed, which is 3 over 5 cubed. 3 times 3, 9. Times 3 again is 27. 5 times 5 is a quarter. 5 quarters is 125. So our final ratio of volumes is 27 to 125, or 27 over 125. Now, a different way we could ask a similar question here is, given that the solids A and B are similar, solid A and B has a ratio of sides 3 to 5. Find the ratio of the surface areas of A to B. So, A over B is 3 over 5. We want A squared over B squared, which is going to give us 9/25. If A now has a volume of 108 centimeters cubed, what is solid B's volume? Again, another way we can ask these questions are dealing with the surface area or dealing with volume. So now we want cubed because we're dealing with volume. So 3 cubed over 5 cubed, what we just did last slide, is 27 over 1/25. And now I'm going to set this equal to 108 over the volume of B. Cross multiply and divide, or find your rule of times 4. And we're going to get 27 VB is 125 times 108, divided by 27, and we get 500 units are centimeters cubed, so our units down here are also centimeters cubed. 2 more questions, and we've got figure 1 is similar to figure 2. Find the value of x. Surface area of this unit is 156. The surface area of unit 2 is 624. So 156 over 624 is a squared to b squared. That simplifies to 1/4. And now when we square root, we're going to get square root of 1 over square root of 4. For our side ratios, it's 1 to 2 because these are sides. And now we're going to say 1 over 2 equals 3 over 10 minus x. Cross multiply and divide, we get 6 equals 10 minus x. 10 minus what number is 6? X is 4. So I don't do the 2 or 3 steps to solve. I just try to look at it in a practical way. A little quicker to solve. Plug it in. 10 minus 4 is 6. 3 to 6. Square it. 3 to 6 is 1/2. And square it to get 1/4. So it worked. One last question. And we have, similarly, we've got the radius of 1 is x and the radius of 2 is 9. Surface area is 266 pi versus the surface area over here is 2,394 pi. Using our ratios, 266 pi over 2,394 pi, this is going to simplify to 1/9. Square rooting 1/9 gives us 1/3. Right, because we have squared because they give us surface area. So that's why these are squared. Why aren't they just the original? We're solving to make a proportion with the original and x over 9. So we found our ratio here is 1 to 3. What's x going to be? You could probably solve it mentally at this point, but 3x is 9, x is 3. And that finishes today's lesson. If you have questions, feel free to message or email me.